This is the question number 14 of combined maths paper 2. This is the day before yesterday exam paper question. So part A is in vectors, right? Part B coplanar forces. Part A sum, very easy sum. You are given the 4 points A, B, C and D. As position vectors, simple A, simple B, 3A, 4B, like that. But you know, two vectors, if one vector is multiple of other, then they are parallel, right? But A and 3A should be on the same line with OA. A and B are non-zero vectors. So if you mark A here, if you mark vector A here, right, where will be the 3A? 3 times A is somewhere here. So 3A is somewhere here. Right. Then if you mark B here like this, 4B should be 4 times B, that is somewhere here. 4B. Right? Somehow O, now A is capital A, point capital A, this is capital B, T is capital C, this is capital D. O is the origin. So AD and BC intersects at E. So this is E. So this O is the origin. So O is A. So this is A. So this is B. Now you have to find it in by applying triangle law of vector addition. So you have to find the expression for vector OE, right? If you take O, if you take this triangle, OAE triangle, from the triangle OAE, we have O with OE equals OA plus AE. That is simple A plus AE. Now you can consider collinear conditions. But since A, E and D are collinear, so AE equals lambda times AD. That is lambda times OD minus OA. That is lambda times OD is 4B, 4B minus A. Then you can write down AE equals OE equals A plus lambda times 4B minus A. So this is 1. So you can get similar expression for OE along the triangle, considering the triangle OBE. From the triangle OBE, OE equals OB plus BE. OB plus BE. That is B plus BE. Since B, E and C are Pauline, BE equals mu times BC, that is mu times OC minus OP. Mu times OC is 3A minus B. Where if you substitute OE equals B plus mu times 3A minus B. So this is 2. By 1 and 2, A plus lambda times 4B minus A equals B plus mu times 3A minus B. So this equals 1 minus lambda minus 3 times simple A plus 4 lambda minus 1 plus 3 mu times B equals 0. Now you have two equations because A and B are null, non-parallel vectors. These coefficients separately equal 0. So therefore 1 minus lambda minus 3 mu equals 0 and 4 lambda minus 1 plus 3 mu equals 0. So 4 minus 4 lambda minus 12 mu equals 0. So if you take this is 1, this is 3, this is 4. If you take 3 plus 4, 3 plus 4, lambda, 4 lambda get cancelled. 4 minus 1 minus 9 mu. Here equals 1 minus lambda plus 3 mu equals 12 mu minus 12 mu plus 3 mu equals minus 9 mu equals 0. This equals mu equals T over 9, that is equals 1/3. One here not 3 mu, here just mu, right? Equals now if you add 3 plus 4 you get here 4 mu, 2 mu minus 11 mu equals 3 mu equals 3 over 11. 3 over 11. Mu equals 3 over 11. Now if you substitute mu equals 3 over 11, you can find OE. Then OE equals from 1, OE equals B plus 3 over 11 times 3A minus B. So this equals 11B plus 9A minus 3B over 11. So this equals 1 over 11 times 8B plus 9A. 8B plus 9B. So that is part A. Now you can do part B. For part B, you are given 3 forces, F1, so you can take 3 forces are given, alpha I plus 2J minus 3I plus beta J, I plus phi J are 3 forces acting at the point with position vectors I plus J, 3I plus J, 2I plus J respectively. Alpha, beta are real numbers. Now you have to show if the system is equivalent to a couple, find alpha and beta, right? So you can take 3 forces as F1, F2, F3. Let F1 equals alpha I plus 2J, F2 equals minus 3I plus beta J Ft equals I plus phi j. If the system reduces to a couple, then resultant vector is given by F1 plus F2 plus F3. So this is equal to 0. Okay? Alpha I plus 2j minus 3i plus beta j plus I plus phi j. So this equals alpha minus 3 plus 1 times I, 2 plus beta plus 5 times j. Alpha minus 2i plus beta plus 7j. So this is the resultant. If the system reduces to a couple, if these three forces reduce to a couple, then R is null vector. So then alpha minus 2i plus beta plus 7j equals 0. The alpha minus 2 equals 0, beta plus 7 equals 0, alpha equals 2 and beta equals minus 7. Then you can rewrite these forces. So these are the three forces. You can rewrite these forces. So this equals 2i plus 2j minus 3i minus 7j, and this equals I plus 5j. Right? Let's see how they are acting, what point. Now these forces act at I plus j. These act at 3i plus j, this one at 2i plus 2j, right? Now you can mark these forces. All these forces you can mark on the Cartesian plane like this. This is y, this is x, 0, 1, 1. At 1, 1 there are two forces. At this point is 1, 1, here also 1. At this point there are two forces, 2, 2. In this direction there is 2 units, another 2. Then second force F2 exacting minus 3 plus 3 j. That's T1 point. This one T at this point. This point is 3. At that point minus 3 is like this. Minus 7 is like this. Then other one is 2, 2, 2 point like this. So coordinate at this point is 2, this point is 2. At this point force of 1 unit in this direction, force of 5 units upward direction, right? Those are the forces, 6 forces. Now you can take moment about rho. Let G be the moment about O, anticlockwise moment. So 2 into 1 minus 2 into 1 plus 3 into 1 minus 7 into 3 minus 5 into plus 5 into 2 minus 1 into 2. So if you simplify this thing, 3 minus 21 plus 10 minus 3. T so right. So 1 into y into 2 minus 1 into 2. P minus 21 plus 10 minus 3. So this equals minus 11. This equals minus 11. So now you can take again a new force is T gamma I. So you can take that force is F4. New force is new force T gamma I plus 4 gamma J is added to the system. Then system is reduced to then the system is in equilibrium, right? Then if you take like this, so now there's a couple of minus 11, but at the center these two forces at the center, that is T gamma and 4 gamma. When you add this forces to the system, that now system reduced to a single force. Suppose that single force is acting, this one you have to find the line of action of single force, right? If it is acting, let's say it is resultant cut to the x-axis at this point. That point, coordinates of that point you can take A0, right? Then if this resultant force is 4 gamma as 3 gamma. Now you can take moment about O for the both systems, that is 4 gamma into OA equals minus 11. OA is simple A, that is 4 gamma into A equals minus 11. So A equals minus 11 by 4. Here G equals here 3 minus 21 plus 10 minus 2. This should be minus 2. minus 2, then this equals minus 10. G equals minus 10. So this equals minus 10. Minus 10 over 4, that is minus pi by 2. Minus pi by 2. Okay. Now you know one point, and you know the gradient tan theta. If you take this angle is theta, so theta equals 4 gamma over 3 gamma, that is 4 by 3. Then theta equals tan inverse 4 over 3. Right? So you have to find the single resultant force. Okay. So you have to find the equivalent to resultant force. Actually it should be single resultant force. Single resultant force, and find its magnitude and direction and line of action. Right? So this is the direction is given by theta, and magnitude is actually magnitude of three gamma squared plus 4 gamma squared whole thing square root. So this equals 5 gamma. Now finally they say that before that we have to find a line of action. So equation of the gradient of the line action is tan theta, that is 4 by 3. Therefore, equation of the line y minus 0 over x minus pi by 2 equals 4 by 3. Sorry, A equals here 4 gamma is minus pi over 2 gamma. A equals minus pi over 2 gamma, then here A value of A equals minus 2 over 2 gamma. Pi over 2 gamma equals this. In terms, actually you can find the equation of line in terms of gamma, right? So 3y equals 4x plus 20 over 2 gamma. So 3y minus 4x minus 10 over gamma equal 0. So this is the equation of the line. Finally, they say that last part, the force of Pi plus Qj acting to the point with position vector T I 2I plus Tj added to the system. So at this point, let's say this point, this actually 3I 2I plus Tj, this point. Oh, that is the point, Cartesian point is 2t. At this point, this is two forces Pn Pi Qj is added. But if it is equilibrium, then other forces 3 gamma I, if it is equilibrium, then so this is the resultant force, and this force should be in the same line and opposite direction line. Okay. Then both other two forces, the new system is R dash, then R dash equals P plus 3 gamma I plus Q plus 4 gamma G. If it is in equilibrium, this should be equal 0. Then P equals minus 3 gamma and Q equals minus 4 gamma. And the equation of the line should pass to 2T point. So therefore Ty minus 4x, Ty minus 4x, Ty minus 4x minus 10 over gamma equals 0. So we can substitute this point 3 into 3 minus 4 into 2 minus 10 over gamma equals 0. 1 equals 10 over gamma, so gamma equals 10. If gamma equals 10, then P equals minus 30 and Q equals minus 4. Right? So these are the values.